A program I created using two NXTCams, and what this does, this will track an object and tell me the elevation of the object. It'll tell me a horizontal heading of the object, and it also can judge the distance fairly accurately, how far away this object is, by using two cameras. Now what this bolt is here is I have a base with a motor in it, and I've got a turntable gear there, and it's set up to turn the whole assembly, and the program is keeping the object in the center of view. Let me turn this around. Now you can see there's a second motor, and that's controlling the elevation. And again, all the program is doing is keeping the object in the center of view of camera number 1. And you can see I have two NXT cameras there, and they're approximately 4 inches apart. This here is a compass used to get the heading, and this is a tilt center sensor, and all it does is when I first initialize the program, it finds the level point for the elevation and sets the counter on the motor to 0. It's kind of hard to read the screen on a brick, so on the laptop I have a program called here NXT Screen, and it's displaying whatever's being displayed on the brick screen. So the top vertical line is the azimuth or the heading, and you see if I move it off a little bit, the heading changes. If I move it back, the heading changes back. This is magnetic heading. The bottom horizontal line represents the elevation. If I go down, you see how it's beginning to look down, and if I go up, the cameras are looking up to track the object. Now the vertical line on the right hand side represents the range, and if I move it away, the line gets longer, and if I move it closer, the line gets shorter. Now this is what I call a tracking display here. And you can see the 1 is the center of the object from camera number 1, and the 2 is the center of the object from camera number 2. The line down below represents the range. So if I move it closer, you see how the 1 and the 2 are getting further apart, hence the range is getting shorter. If I move it further away, the 1 and the 2 move together, and hence the range is getting longer. Now you see here camera 2 has lost the object. There, the car comes back. And of course, when I move up, I get a U in the upper right hand corner. If I go down, the D means move down, left, or move it to the right. And basically what this system is doing here, by looking at this ball from two different perspectives, I can figure out the distance between the center of the object from each camera's view and determine the range fairly accurately. Now something else I want to demonstrate here is the size of the object makes no difference to the range detection. You can see here I have a range of about 19 to 21 with about 1.5 inch ball here. And you can see here I'm getting approximately the same range with the 4-inch ball. That display is kind of updating a little slowly there, but you can see that the range is staying fairly consistent no matter what the size of the ball. Now, many of you may not have two NXT cams, so it is possible to track the range with just one camera. And here's a modified version of a bolt that can do that. You can see I've only got one camera, and I am tracking the range. And the way this works is I have to tell the program the size of the object that I want to track, and then it'll track it. And here's how it works. The two lines in the upper part of the display are displaying the width of the set width that the program is looking for. The two lines in the center of the screen are the actual width that are being returned. So if I move it closer, you see how it gets bigger? And the range line at the bottom gets shorter. If I move it further away, the width gets smaller. The range line at the bottom gets bigger. Now the problem with this is, you can see here that I've got a box, about a 1.5 inch ball here, and the width is approximately equal to the set. If I change it to a bigger ball, you see the width here is quite a bit bigger, and the range is a long ways off. And of course, if I get it so close that it takes up the entire view of the camera, it tends to go negative range. Now I can calibrate this. See, I just calibrated it, so now if I go out further, I can actually get a workable range. Unless, of course, I'm taking up the view of the entire camera, then range tracking is not possible. I would like to point out in the user guide for the NXTCam that there is a warning in there. Do not connect the NXTCam to any motor port, as the voltage applied to the motor may damage the electronics in NXTCam. If you notice on my projects here, I put colored wire on there so as to help minimize that difficulty. As you can see, now I am the saddened owner of a $100 paperweight because it was plugged into a motor port. Be careful.